Verifying the mathematical statement. Show that an equation of a circle with x1, y1 and x2, y2 as the endpoints of a diameter can be written in the form x minus x1 times x minus x2 plus y minus y1 times y minus y2 is equal to 0. Hint, use the fact that when the two endpoints of a diameter and any other point on the circle are used as the vertices, for a triangle, the angle opposite the diameter is a right angle. So let's go. Here, as we know, according to the Thales theorem, any triangle inscribed in the semicircle is a right triangle. So it was a point here, and this triangle I just moved in the middle, and still the diameter is the same with the endpoints x1, y1, x2, y2. And the xy is equidistant from x1, y1 and x2, y2. First of all, let's write this distance between these 2 points with the d2. And the distance between these 2 points here, x1, y1, and xy, let's denote with a d1. And the diameter, let's denote with a d, with a small letter d. So now, according to this fact, because this is equidistant here, now we already know this d1 is equal with d2. With d2. And the other fact what we know, the x coordinates x minus x1 is equal to the x minus x2. So x minus x1 is equal to the x minus x2. So let me collect here some facts that when I need it later on, I'm going to take from here. x2. And also the y coordinate, y minus y1 in this distance is going to be equal with the y minus y2. And the other fact is that the distance formula, we can write d square. Let's say for d1 square, I need just one side of the distance. Those are the same, equal. Is equal with the x minus x1 square plus plus y minus y1 square. So I need these facts when we are showing this statement is true. So now, according to the Pythagorean theorem, this triangle here is inscribed in the semicircle is right triangle, and this is hypotenuse. Those are the sides of the triangle. According to the Pythagorean theorem, d square is equal with d1 plus d2 square. So the hypotenuse is equal with one leg of the triangle square plus another leg of the triangle square, d2 square. And now we already know the fact d1 is equal with d2. So let me write this d square can be equal with d1 plus d1 square. Instead of this d1 d2 square, I am plugging in, or I'm substituting with d1 square. And now those are, if I'm adding, because the same items, I can write this is equal to the 2 d1 square plus d1 square is 2d1 square. And now I have this fact here. Now d square, I am going now to write in the form is equal to 2. And let me open here a bracket. And instead of d1 square, I am going to use substituting x minus x1 square plus y minus y1 square. So let me write this substitution. X minus x1 square, everything is a square, plus y minus y1 square. Y minus y1 square. So we are in this position here now. And now let's assume d is equal to 0. The diameter is equal to 0. If the diameter is equal to 0, we can write this way. 0 is equal with a 2. And now let me write everything here. Instead of a x minus x1 squared, let me write a x minus x1, x minus x1, or I will write in the way how it is, and just let me divide everything by 2. So I will make one extra step. Minus y1 square. And now this we divide by 2 everything, and 2 is going to disappear. 0 divided by 2 is just 0. And now let's write 0 here is equal. And instead of the x minus x1 square, I'm going to expand to write in the expanded form. X minus x1 square, I can write in x minus x1 times x minus x1. So I can write this way. X minus x1. And now I can close parenthesis, plus same thing I'm doing for the y minus y1 square. I will write y minus y1 times y minus y1. But here now we are going to use another substitution. Whenever I have x minus x1, I can substitute with x minus x2, and y minus y1 I can substitute with the y minus y2. So now I can write this 0 is equal. But the first x minus x1 I will write it the way how it is. I'm not making any changes. X minus x1. But for the second factor, x minus x1, I'm going to substitute with the x minus x2. So this I'm going to change. X minus x2. And now I can close this parenthesis, and I can plus. Again, y minus y1 I write it the way how it is. I'm not making any changes here. Y minus y1. But on the other factor, in the second factor, I am going to replace by, instead of y minus y1, I'm writing y minus y2. Y minus y2. And the last statement here completes the proof, which is equal with this statement here, what we were trying to prove it.